Okay, so there was some technical glitch, and that is why I had to begin once again. So, again, welcome everyone, and good afternoon. I hope you all are doing well and everything is fine. So, in today's class, what we are going to do is okay, yeah. So, in today's class, what we are going to discuss is we are going to discuss questions from ray optics. And as I said in the previous weekend class, I told you we will be discussing questions from instrument, and that is simple microscope, compound microscope, and telescope. Okay. So in today's class, we are going to discuss last part of ray optics, and after that, we will be discussing some other chapters or something else. Okay. So what we are going to discuss? सबसे पहले I will give you overview of all the topics that we are going to deal with today. Okay, so questions we will be picking up from simple microscope, compound microscope, and telescope. So let's start with a brief idea of what these things are and what formulas actually we require to solve questions from simple microscope first. Okay, so simple microscope is what? Simple microscope is basically a magnifying instrument. Okay, so suppose you have something of diameter or radius of the range of 20, 10 to the power minus 6 meter, suppose, and you want to magnify it to the range of millimeter. Then, so what we need to do, we need to look at it through lenses, through something that can magnify it. Done. So simple microscope won't do magnification for that range, but yeah, if there are small letters in book or some copies, if you're getting and you want to just get it more magnified, in that case we can use simple microscope. Okay, so simple microscope is nothing but a convex lens. Okay, and if you remember, because we have already studied what ray optics, so you all must be aware of when we get erect magnified image in case of convex lens. So it is that case when object is kept between focus and optical center. So in simple microscope, what we do is we keep object in between focus and optical center. Okay, so we do such kind of thing. Now, what will happen if object is kept like this? So image will get formed something like this. They won't meet actually, this refracted range won't meet actually, as is the case with image formation in this condition. And if we will extend these rays backward properly in a straight line, we will get an image here. And this is called virtual image, right? We have already gone through it. So simple microscope is nothing but this. And in simple microscope, what we do is we keep our object to be magnified in such a way that it lies between focus and optical center of that simple microscope, and then we get the magnified erect image of that thing. Okay, so this is what we do basically. Done. So this is simple microscope. Now in your textbook, you have to calculate magnification thing. And how we calculate magnification? So we have to learn about एंगुलर मैग्निफिकेशन. ठीक है, ये चीज तुम लोग ध्यान में रखना. We have to learn about angular magnification. Again, I have gone through all these topics already because we are done with ray optics. Done. So angular, इसलिए मैं थोड़ा fast जाऊंगी. So pardon me for that, but yeah, I will be going a bit fast because I've already dealt with all these things. So angular magnification means how much angle object will form at the naked eye. So if my eye is like this and I'm directly looking at the object, kept at least distance of distinct vision, that is the 25 centimeter, right? So how much angle will it form at my eye? Let's say this is alpha, okay? And now you just try to look at this object. The same object is here. And now look at this object through microscope. So through lens, I'm looking at the object. And in this case also, this will form certain angle at my eye, say beta. So angular magnification, that is magnification that we have to study in this case, is equal to how much? Beta by alpha. So if we will solve it, we will get two cases. हमें दो cases पढ़ने हैं. First case is what? Case one. ठीक है? First case. So first case is what? When we are looking at the object through lens whose image is getting formed at infinity. ठीक है? So that is called relaxed vision. Now, what do you mean by relaxed vision? Relaxed vision means you are looking at the object. You are looking at the object. Suppose this is object, okay? And this is my simple microscope. So this is lens, and I'm looking at my object through lens. So my eyes are here, and its image will get formed somewhere where infinity. Done. So first case is when we are looking through microscope, and microscope is actually forming the image of this object at infinity. So this is relaxed vision. I have explained you why this is called relaxed vision. Okay. So in this case, our magnification formula, that is beta by alpha, stands to be how much? D by F. Where D is what? D is distance of uh, sorry, like this is the distance at which we can see object very comfortably. Uh, that is near point it is, and for our eye, near point is 25 centimeters. So if nothing is given in the question, take D as equal to how much? 25 centimeter. And if things are given, then you write a value of D accordingly. That's your concern, or that is how you have to proceed with questions. Okay. And this F is what? This is the simply focal length of this lens. So this is first case, relaxed vision. And second case is what? If I talk about second case, in second case, what will happen? Again, we are looking through microscope because we are calculating magnification for what? Magnification for lenses. Sorry, simple microscope. Then, so there is an object, and here what we are doing, we are looking at it through, this is my eye, through microscope, and final image is getting formed somewhere at distance which is equal to near point. Okay? So there will be two cases. Final image will get formed either at infinity or at less distance of distinct vision. These two can be the cases. Okay. So in second case, magnification is how much? 1 plus d by f. So if you see carefully, in first case, magnification was d by f. In second case, magnification is d by 1 plus d by f. So in second case, magnification is greater by 1. So which case we will prefer? So that will depends on what we want or what is our outcome. Like if you want no stress on our eye, then we will get with first case. Okay. And if we want magnification to be a bit higher by 1, I must say, then we will go with second case. Okay. So this is for simple microscope. Now, what happened with simple microscope? In case of simple microscope, this M can't be greater than 9. So its range is how much? Greater than equal to 9. So of these 9 times it can magnify things. But if we have to magnify things beyond it, 10 times, 20 times, or more than that, then we can't do that with simple microscope. So for that, we need compound microscope. And here what we will be doing, we will be taking two lenses. Okay. Because first lens will magnify object to some extent. Second lens will again magnify that magnified image. Okay. So double magnification will happen. And that is why here magnification will be higher. So what are these things called? First lens before which object is kept is called objective lens. And lens behind which my eye is present, that is called eyepiece. Okay. And here, one noticeable thing is that aperture of objective lens is less than that of eyepiece. And the reason being, I have explained extensively in detail, but here also I will let you know, like aperture is small so that a bright image of this small tiny object AB can be formed. Because here AB is very small, exaggerated image or exaggerated size of object AB is shown in the diagram because we have to form its ray diagram. Otherwise, before compound microscope, we put very small things, right? So this aperture is small of objective lens so that light coming from the small object that is already small should not get dispersed much. It should get concentrated to one point, uh, and that one point will be its image, right? So that is why we are not enlarging its aperture to that extent. Okay, this aperture is small with respect to eyepiece. That's the reason. Now, what will happen? So we all have learned about combination of lenses. I have told you if there are two lenses in combination, just in touch, or even if they are not in touch, so total magnification will be what? It will be magnification by one lens into magnification by two lens. The second lens, right? So total magnification will be M1 into M2. And here also same thing will happen. This image, this object's image will get formed first by objective lens, and that image will be magnified, suppose somewhere here. And this magnified image will act as an object for eyepiece, and again its image will get formed, again magnified image. So further magnification will happen, and that is why net magnification will be how much? More than that of simple microscope, that is M1 into M2. Here also we will go through two cases. You first see the ray diagram. So here the ray diagram is like this. ठीक है? अब देखो फाइनल इमेज मेरा आइदर इंफिनिटी पे बनेगा या फिर एट लीस्ट डिस्टेंस ऑफ डिस्टिंक्ट विजन दैट इज नियर पॉइंट. ठीक है? सो इन दिस डायग्राम इमेज इज गेटिंग फॉर्म्ड एट लीस्ट डिस्टेंस ऑफ डिस्टिंक्ट विजन. ठीक है? So how we will write the magnification? Our task is to write m net, and for that I need m1. M1 is equal to what? And then I need what? Then I need m2 is equal to what? Okay. So I need these two things. What will be M1? Magnification of lens formula is what? V by U. So here for the case of objective, we will just see that what is the object distance. So it is U naught. What is the image distance? It is V naught. So M1 will be equal to V naught by U naught. Simple. ऐसे लिखना है, ठीक है? M2 will be what? M2 will depend on image is getting formed at which point, final image, right? So this, let me tell you, this eyepiece acts as a simple microscope. So if final image is getting formed at infinity, in that case, M2 will be what? M2 will be your D by Fe. And if final image is getting formed at least distance of distinct vision, in this case, uh, M2 will be 1 plus D by Fe. Remember here, F is Fe because here eyepiece is acting as a simple microscope. So this is, so total magnification will depend on cases. M1 will remain same in both cases, that is V naught by U naught. Then, so total magnification, if I write total magnification here, so for first case you already know, when final V is at what? Infinity, in that case, magnification will be V naught by U naught into D by Fe. And in second case, when final image is getting formed at least distance of distinct vision, this is V final, this is V final, remember. So this will be equal to V naught by U naught into D by Fe plus 1. Okay, this is this. Okay, what is U naught? Is the distance of object from the objective. What is V naught? Distance of image getting formed by objective. Okay. Now there is a slight approximation that we use here in some questions. Okay. So what approximation we use, that I will discuss today because that is very important to know actually. So, a second. So what approximation we use? Then, so there is a term, just remember, I have discussed it already, but let me do it here also. So that term is called what? That is called tube length. Okay? So a term है that is called tube length. ठीक है? Tube length of compound microscope means what? Tube length of compound microscope means distance between focus of objective, that is this point, and distance between 2 points, one point being focus of objective and another point being focus of eyepiece. So suppose Carlo, this is a focal point of eyepiece, suppose. So distance between these two will be called what? tube length. ठीक है, but it is seen that mostly tube length will approximate to, or it will become equivalent to in most cases, or if we take approximation and all, it will become equal to this distance, yani ki distance between objective and eyepiece. Okay, so that thing I've discussed in class also, why it is happening actually. If I let you know here, just let me discuss in the previous diagram, because that is more clear. So if I talk about here, magnification by objective, if I talk about, that is M1, it will be more when, if you remember in image formation in case of convex lens, so if this is the focus and this is center of curvature, you already know that image, real image, real magnified image we get when object is kept between C and F. Done. And as our object move towards F, that magnification increases even further. Okay? So in this case, what happens? Objective or object is kept very close to the focus. This is very close to the focus. So U naught, that is object distance. In the next diagram, we have seen already. So U naught, we can approximate U naught to what? F. F naught. Okay, so एक approximation ये हुआ, and this is very logical. Okay, we use it when according to question we will use it, not always, and that will become very much visible with the question. We are going to solve it just after 5 minutes. So first thing is this. Second thing, when जैसे when object is between C and F, image will get formed where? Image will get formed beyond C. है ना? Image will get formed where? Beyond C. And if image is getting formed beyond C, so let's say this is F naught. Again, lens will have two focus. So this is also F naught. And double center of curvature means double of F naught. So if image is getting formed beyond F naught, we can say that image is getting formed very close to the eyepiece. So we can say that image distance is approximately equal to the tube length. Okay, so image distance को हम लोग approximate किससे कर देते हैं? Tube length से. This is very important if you are going to solve the question, and question came in 2022, 23 also, right? So these two things are very important. So now let me summarize things that I have already taught you. So here I told you approximation if you're going to use for V naught and U naught. So we can approximate V naught to L, and L is what? L is your tube length. Ideally, tube length is distance between focus of objective and focus of eyepiece. But it almost becomes equal to distance between objective and eyepiece. We can approximate according to question. अगर question में दोनों lens के बीच का distance दिया है, we will consider that as a tube length. And if distance between focus of objective and focus of eyepiece is given, we will consider that as tube length. Okay. So depending on what question is saying, we will do that. And U naught I approximated to F naught. I did, why I did this, you already know. Okay. So M naught, that is M1, is can be written as L by F naught. Remember, according to question, we can write. If in the question L is given, F naught is given, and nothing is given about U naught. If U naught is given, we can calculate V naught by using lens formula. But if it is not given, these things are given, it means we have to go for the approximation, and we will go with it. Okay. So that is all we have to do. Now let's move on to astronomical telescope. Telescope का काम क्या है? दूर की चीजों को देखना, heavenly bodies को देखना. Done. यहाँ पे we will have again two lenses. One will be your objective, जो object के पास होता है. One will be your eyepiece, जिसके behind हमारा eye हो. Done. So here you can see directly, just by looking at the diagram, आप देख सकते हो objective has a higher aperture. Why? Because we are looking at the object very far from us, and if we want its image to get formed very much clearly, this lens should gather more light, and for that its aperture should be what? Larger. And also I discussed in the last class only, the aperture should be larger for better resolution of images. So please go through that video for further things. But here I will just give you what? Formula. So we are looking at far object, so definitely object is at infinity, image will get formed first at the focus of what? At the focus of what is that called? Objective, right? So at the focus of objective, because object is at infinity, image will get formed at focus, and final image here also will get formed at infinity. So in case of telescope, we are just considering one case, that is relaxed vision. It's हमारे syllabus में यही है. So we have to read this only. And here also magnification क्या लिखोगे? Beta by alpha, angle getting formed at naked eye by angle getting formed, sorry, angle getting formed at aided eye, that is when we are looking at the object through telescope, then how much angle it is forming at our eye. And alpha, when we are looking at the object without any instrument, that is with naked eye, then how much angle it is forming. So if our eye is here, that is before telescope, that is directly we are looking at the sun or moon, whatever it is. So then it forming how much angle? Alpha. And when we are looking at the object through telescope, it will form at our eye angle beta. Okay. So we have done all this calculation. मैं यहाँ पे formula लिखने वाली हूँ. And this formula will be equal to how much? If you calculate, it will be equal to F naught by Fe, if I'm not wrong. Uh, yes. Yeah. This is it. Here also we discuss about tube length. So this is simply distance between these two things. And this is equal to, tube length is equal to F naught plus Fe. Why F naught plus Fe? Because देखो image is getting formed at F naught and final image is also getting formed at infinity. It means this point must be focal point for the second lens also. So this distance is also equal to focal length of eyepiece. And this is equal to focal length of objective. So total length F naught plus Fe. And this is your ट्यूब लेंथ फॉर टेलीस्कोप. ठीक है. सो ये सारी चीजें अब हम लोग क्या करेंगे, क्वेश्चन में अप्लाई करेंगे. तो चलो हमारे पास सबसे पहला क्वेश्चन है ऑन योर स्क्रीन. टेक सम 1.5 मिनट एंड ट्राई डूइंग इट. ओके. सॉरी. चलो करो, मैं यहीं बैठी हूँ. आई विल see your activities in the chat box if you're going to reply. And it will be very good if you can answer me your queries. Okay. Actually, I was having problem in my eyes, so that is why I switched off the light. It was like simmering so much. Sorry for that. I hope you have understood the question. Let me check if this is the first question. No, no, this. Okay. See here carefully what is given. Object distance is given. So while reading telescope, we have kept object at infinity. But if in the question it is given like the object distance is this, then we must solve accordingly. Okay. So solve accordingly. So final image will finally get formed at infinity itself. Then, because nothing is given in the question about final image is getting formed where. Then that is not given. So if that is not given, we are going to assume that final image is getting formed at infinity. But about object, the question is talking, right? It is saying object is kept 200 centimeter away from the objective. Done. So yeah. इन द एग्जाम इस टॉपिक से क्वेश्चन नहीं छूटने चाहिए क्योंकि क्वेश्चन काफी इजी होता है. ठीक है. सो आई होप यू पीपल विल कीप दिस इन योर माइंड. Okay. Uh, are you getting answer or should I do it? Yeah, I'm having look at YouTube also. I can see your chats. So you can communicate, you can answer me, or whatever problem you're having, you can just text me that also. Okay. So let me know if you're having any trouble. I will be more than happy to solve that. Okay, anyway, if you're not getting answer, it's not a worry, but you try it for sure. Okay. So try it, then only you will understand where you are getting stuck. Because before somebody tell you the whole procedure of making the question, you must have gone through your own step of making the question or solving the question. Then only we learn in real way, right? But without trying, if you're going directly to solution, it's not going to help us. So that is why I time and again stress on students solving question, even if they're getting wrong answer. I know that will help because when I was a student, I know what is like importance of solving questions, not just getting answer. Getting answer is important in examination hall. Before that, when we are just starting with the chapter, we should be just solving the question. Okay? Without minding much about if we are going to get correct or answer or a wrong one. Done. So चलो मैं इस क्वेश्चन को करती हूँ. You all might have done it. I'm assuming that. So now there is a astronomical telescope and it has objective eyepiece. Objective focal length obviously it will be greater. So its focal length is 40 centimeter and eyepiece focal length is also given, that is equal to 4 centimeter. Then what is given in the question? क्वेश्चन में क्या दिया हुआ है? टू व्यू एन ऑब्जेक्ट 200 centimeter away from the objective. So there is a question object that is not kept at infinity, but some at some finite distance it is kept, and that is 200 centimeter. ठीक है? Away from the objective. The lens to view an object 200 centimeter away from the objective, the lens must be separated by what distance? So what should be happening here? This is object. मैंने इसका थोड़ा enlarged image बना दिया. Let me shorten it so that I can pass rays coming from it. So this is my object. Okay. So ray of light coming from it will pass like this. And this will form an image here. And then its image will get formed like these rays will also pass through the lens. And they will pass through what? Uh, uh, देखो मैंने रे डायग्राम सही से नहीं बनाया है, सॉरी फॉर दैट. लेकिन ये फाइनल इमेज कहाँ बनेगा? इन्फिनिटी पे बनेगा. समझ रहे हो? फाइनल इमेज कहाँ बनने वाला है? इन्फिनिटी पे बनने वाला है. नाउ वी आर आस्क्ड व्हाट इज द डिस्टेंस बिटवीन दिस एंड दिस. सो कांट वी डू वन थिंग? अब देखो, जस्ट बाय ड्रॉइंग द डायग्राम, करेक्ट रे डायग्राम बना रहे हो या नहीं बना रहे हो, दैट डजंट मैटर मच हियर. व्हाट मैटर्स इज हाउ मच क्लैरिटी यू आर हैविंग अबाउट थिंग्स. जैसे you know that if object is at 200 centimeter, there will be some image distance, then not equal to the focal length of objective, definitely, because object is not at infinity. So we need to calculate from lens formula. We can do 1 by v minus 1 by u equal to 1 by f. So for objective, u is given, that is 200. F is given, that is 40 centimeters. So with proper sign convention, we can put the values and get the value of v. So v we will get. Now, this distance is v. अब तुम खुद सोचो, if final image is getting formed at infinity, it means this distance must be equal to, that is object distance for eyepiece must be equal to what? Focal length of eyepiece. So this distance or tube length will be equal to how much? Tube length will be equal to V plus Fe. Earlier I said you tube length for telescope is equal to F naught plus Fe. When object is at infinity. So first image is getting formed at the focus of objective. And also last image is getting formed at infinity. But here what is happening? Object is not at infinity. First image is getting formed not at focal length of objective. We need to calculate that. And definitely final image is getting formed at infinity. So definitely this point is going to be the focal point of eyepiece. So tube length will be V plus FE. FE we already know 4 centimeter. What will be V? V क्या होगा हमारा? So V we can calculate, right? V will be how much? चलो बता दो कितना होगा V? So 1 by V minus 1 by U का value put करो with proper sign convention. So that will become minus 200. And since this is a convex lens, focal length will be positive. So that is equal to 40. 1 by V is 1 by 40 minus 1 by 200. So as this is my favorite thing to make denominators same, that is why I multiplied and divided by 5. And this is equal to 4 by 200 and that is equal to 1 by 40, 50. So V equal to 50 centimeter. Now what will be the tube length? कितना होगा आप बताओ? What answer you will get for tube length? Yes. Okay, so it will be how much? It will be 50 plus 4. Okay, that is centimeter. Over. चलो ठीक है. So now, so answer was B. B is 54, right? So correct answer we got. Now let's move on to this question. This came in G 2022. So solve it. Take 1.5 minutes and solve this question. Okay. चलो करो तुम लोग. So before you move on to solving question को सही से पढ़ना, ठीक है? Read carefully. Give more time to reading and understanding the question, and then draw the diagram. Done? क्योंकि ray optics में when you are drawing diagram, your half work is already done. Okay, so do that. I hope you all are solving it. Okay, so I hope you all must have gone through the process, or you all must have applied whatever thing you know about compound microscope. And after reading this question, whatever you felt like you must have applied, I'm just assuming that, and after that, I'll explain. Okay. So there is an object view from a near point distance of 25 centimeter using a microscopic lens with magnification 6. Just put more emphasis on the or on the way language is written, question is written, right? If you look at here, what is said that object is viewed from a near point distance. So let's say this is simple microscope. Using a microscopic lens, it is given, right? So if it is talking about microscopic lens, means it is talking about simple microscope. Okay. So an object is viewed from a near point distance of 25 centimeter. So object must be kept somewhere else, and this object's image must be getting formed at this point. Okay. So we just need to have eyes here. Okay. So this is one light and this is another. They are meeting somewhere. Okay. Done. So what is written? We are able to see object, and that is getting viewed from a near point distance of 25 centimeter through or by using a microscopic lens with magnification 6. So this is magnified to extent of what? 6 times. Now, if I put the formula, which formula I should put? Here, final image is getting formed at least distance of distinct vision, right? So 1 plus d by f, that is f of, f is what? Focal length of this simple microscopic lens. And this is equal to what? 6. Now, d by f, d is how much? 25 centimeter by f, that is 5. So f is equal to how much? 5 centimeter. So focal length of this simple microscopic lens is how much? 5 centimeters. So first statement is done. But the problem is this gives an unresolved image. Means image clarity is not there. So what we will do? We will use another lens, that is we will try to make it compound microscope. Done. So that is getting done here. यहाँ पे देखो, a resolved image is observed at infinite distance with a total magnification double the earlier using an eyepiece along with the given lens. So we are using an eyepiece along with the given lens. यानी कि given lens is becoming objective. Okay. So given lens को आप क्या बना दो? Objective बना दो. So this objective has a focal length of how much? 5 centimeters. And then we are using another eyepiece. And its focal length is not given in the question. Let's say it is FE. And a tube length of 0.6 meter. Here tube length is given. Okay, that is how much? 0.6 meter. And in this case, how much magnification we are getting? So in this case, total magnification that we are getting is M, that is double of the previous one. That is 12. Magnification we are getting is how much? 12. Done. So this much magnification we are getting. Now, what we need to calculate, if the focal length of eyepiece is equal to, so what will be the focal length of eyepiece? Now this magnification will be equal to how much? M naught into ME, that is magnification produced by objective into magnification produced by eyepiece. अब देखो यहाँ पे जो बच्चे कंफ्यूजन कर सकते हैं वो ये है कि they will blindly write magnification produced by objective is equal to 6. Don't do that, because 6 we are getting when? 6 we are getting then when object is kept between focus and optical center, and then virtual enlarged image is getting formed. But in case of compound microscope, objective lens, which is the same microscopic lens. So this objective lens will form a real image. So its magnification can't be equal to 6 over it. So this will be something else. क्या लिख सकते हैं? V naught by U naught into final image is getting formed at infinity. So I told you कि eyepiece will act as a simple microscope while calculating formulas. I told you. So if final image is getting formed at infinity, its magnification will be equal to how much? D by Fe. And this is equal to 12. Now we have to deal with calculation of M naught, V naught by U naught. ठीक है. So is there something given about कि where object is kept in front of simple microscope? It's not given, right? It's not given, only tube length is given. So if tube length is given, just use the approximation, as I said. So if we are going to use the approximation, I told you object is kept near to focus, very close to focus, so that we can get very large image from the objective lens itself for maximum magnification. So U naught will become equal to F naught. And in that case, image will get found very close to eyepiece. And that is why image distance can be taken as tube length. Done. So we will use approximation here. Done. So V naught will be 0.6 meter, that is 60 centimeter. And here U naught is equal to how much? That is object distance. And that we are approximating to how much? F naught. And this is equal to how much? D by Fe. And this is equal to how much? 12. Now we just need to solve it. So अब आप इसको solve कर दो. 60 by F naught is equal to, this is F naught ना? Because this was the focal length of this microscopic lens. And same microscopic lens is acting as an objective. तो यहाँ पे आप क्या लिखोगे? 5. And this is equal to D is 25 centimeter. This is Fe and that is 12. So 12 से ये 5 times में जाएगा. This is 5, 5. Fe will be equal to how much? It should be equal to 25 centimeter, right? So correct answer will be what? 25 centimeter. I hope this is clear. So if this question is clear, you might have understood when to use approximation. So as I said while discussing formula, where you will use approximation, that will become clear with the question. So if in question, there is no discussion about where the object is kept before objective, and also there is no discussion about where the image is getting formed by objective, because if image distance is given, we can calculate object distance. But if none of this is given, but tube length is given, we can go with the approximation. Okay, so this is what we are going to do. चलो बहुत बढ़िया. इस क्वेश्चन को अगर समझ गए हो तो it's too good. Any doubt? You can let me know if you have any doubt. Sorry for this darkness actually. Okay, I will switch on the light again. Just give me 1 second. चलो. Done. Anyone having any doubt? No doubt. Okay. So now let's move on to the next question. Done. So this is the next question. Again, take your 1.5 minutes and solve it. Okay. Chalo. Take your time and do it. Do this question. Let me know the answer or just solve it. This is but very simple question. Came in 2023. Okay. So do it. Okay. So I hope you must have done it till now. Is it done? Or should I give more time? Because can see some people's network are just going off and on then. So should I wait? I'm confused. क्या करूं बताओ. Chalo, so let me discuss actually. There is a compound microscope. So compound microscope will have objective of small focal length, eyepiece of larger focal length like this, or aperture, I must say. So its focal length, objective length of focal length is how much? 1 centimeter. And eyepiece has a focal length of how much? 5 centimeter. Okay. With a separation of 10 centimeters. So this separation is how much? 10 centimeter. Now, the distance between object and objective lens at which a strain on the eye is minimum is. So if you're looking at this compound microscope and a strain on your eye is minimum, it means what? देखो यहाँ पे जो ये point है ना, this is very much significant. So it tells that final image is getting formed at infinity. Final image at infinity. ठीक है? So यहाँ से यही सीखना है. This is this case. So if that is the case, then magnification by eyepiece will be equal to how much? It will be equal to D by FE. Okay, क्योंकि final image is getting formed at infinity. And final image will get formed at infinity only if image formed, just as suppose कर लो, this is object. So image formed by objective must lie at the focus of eyepiece. So this point or this distance must be equal to FE. Done. So this is equal to FE. Now, if this is equal to FE, then this will become how much? 5 centimeter. And this whole length is given as how much? 10 centimeter. So if that whole length is 10 centimeter, this distance will be how much? 5 centimeter. So in the question, we don't need to go with approximation. Here, image distance for objective is already given that we can see, and that is 5 centimeter. So we can calculate object distance. ठीक है क्योंकि हमें निकालना क्या है डिस्टेंस बिटवीन ऑब्जेक्ट एंड ऑब्जेक्टिव this thing we need to calculate at which strain on the eye is minimum. So for a strain on eye to be minimum, image final is getting formed at infinity. This is only possible if image getting formed by objective is at the focal length of eyepiece. And for that, this will become 5 centimeters. So this is also 5 centimeter. So image distance for objective is how much? 5 centimeter. Now calculate 1 by V minus 1 by U equal to 1 by F. Now what will be 1 by V? What is 1 by V? This that is given in the question with sign convention. It will become 1 by 5 minus 1 by U and 1 by F. That is 1. So 1 by U will be equal to how much? 1 by 5 minus 1 by 1. Sorry, 1 by 1. Yeah, that is 1. So this is equal to minus 4 by 5. So U is equal to how much? 5 by 4 centimeter. And if we have to compare with, in the question, this separation is, this distance is given as n by 40. So n by 40 is equal to 5 by 4. So this is 10. N is equal to how much? 50. So correct answer should be what? Correct answer should be 50. So again, this is a very good question that came in 2023, but it's not tough if you really know the concept. You just need to draw the diagram and proceed according to question. That's it. Okay. Now, this is going to be the last question that we're going to do today in the class. So, read the question carefully. And this also came in 2022 or 23. So, let me know what answer you're getting. Okay. Take 1.5 minutes. and discuss it. Okay, chalo. So what answer you're getting? Let me. Really, some people have joined from Gen V's. Why I'm not responding? I'm telling you, I'm really cut up with you people. You people are not supporting at all. You people are not attending classes, just coming when you feel like, going when you feel like. Okay. This is a movie theater, I guess, for which you have very much free ticket. That's okay. Okay, that's okay. No issues. Because you are going to finally suffer. Me not. Me not, definitely. When you were not attending classes, you should also have informed everybody that I won't be able to, why I'm not able to. For some people, I understand they may not be having system, they may not be having internet, but whole class not having internet, whole Pune region students not having access. This is unacceptable. Yeah, this can't be the truth anyway. Chalo, let's focus on the question. If you're really here with the intention of learning. In a compound microscope, magnified virtual image is formed at a distance of 25 centimeter from the eyepiece. Okay. So from the eyepiece where the image is getting formed at 25 centimeter from the eyepiece. So this is the case of near point where final image is getting formed at least distance of distinct vision. So for that case, magnification by eyepiece formula is what? 1 plus d by Fe, where d is least distance of distinct vision, and that is given here. And that happens to be 25 centimeter also. But if value given in question is different, then you have to write that different value here. Okay. But in the question also, it is 25 centimeters. So that is why here it is. The focal length of its objective lens is 1 centimeter. If magnification is 100 and the tube length of microscope is 20, then the focal length of eyepiece is. Now, remember, just see what informations are given here. F naught is given, that is 1 centimeter. है And total magnification is given, that is 100. And also, tube length is given, that is L. L is given as 20 centimeter. But nothing it is talking about where the object is kept, like at what distance from objective, and it is also not said where the image by objective is getting formed. So u naught and v naught is not known. If you have followed the lecture, you must be knowing what is u naught and v naught. Okay. So in that case, we will go with approximation. And in case of approximation, magnification by objective is equal to how much? It is equal to L by F naught. Okay. So this is equal to L by F. Now put the things and get the answer. So L by F total magnification equal to M naught into ME. Okay. Total magnification 100. M naught is L by F naught. L is 20 centimeter. F naught is 1 centimeter. ME is how much? 1 plus 25 by F. Okay. So this is going to be 5. 5 minus 1, 4. 25 by Fe. So Fe is equal to how much? Fe is equal to 24 by 25. Okay. And 4 by 25 we are getting, right? Have we done any mistake here? Because anyway. Okay, so Fe is equal to, okay, I'm writing it wrong actually. 25 by 4. Yes, Sandeep. Sorry. मैंने opposite लिख दिया ना, इसलिए गलत आ रहा है. Okay, so correct answer will be what? 25 by 4. If we are going to solve it, it will be equal to 6.25 centimeters. So this is going to be the correct answer. Okay, so we discuss questions. Or I discussed all sort of questions that can come in your exam related to uh, telescope, compound microscope, and simple microscope. I also discussed theory a bit, and that I discussed in length in weekdays classes. Okay, so I hope this way we are good to wrap uh, ray optics. And from next class, it has already started semiconductor. You all must be ready. So in next weekday class, I will be moving ahead with semiconductor. Okay, and we will catch with wave optics later. Okay. So thank you so much for being here, and I hope you people will pay attention to what is required for you at this time. Okay, so Sandeep, you should not thank me actually because I'm not given you anything because you've not attended any classes. Um, Being a teacher, I'm very soft, but at the same time, I'm very much rigid when it comes to students not being regular in not being disciplined. Matlab, why you people not attending classes? Can you give me one reason? Not weekdays, not weekend. People are not coming. Can you reason it out?